Okay, problem number 6. A hyperbola is represented by the parametric equation x equals 5 secant of t plus 3, y equals 4 tangent of t minus 2. All right, so let's go ahead and write the equation in rectangular form. So one thing you have to remember is that the secant is always going to go with the positive term. And that's because the Pythag identity we get is secant squared minus tangent squared equals 1. So secant is the positive expression, so I know x is the positive expression, which tells me that this is a horizontal hyperbola. So x minus 3 from that plus 3 right there, divided by 5 from that 5 right there, squared minus the square of my y expression. Minus 2 tells me plus 2 when it's in factored form. The 4 there tells me 4 in the bottom when you include it in the entire fraction squared like that, and it's equal to 1. So there we go. We have the rectangular form equation. Now, let us write the equation of the asymptotes. What's nice is that when we use point-slope form, it's going to use that x minus 3 factor right there. It's going to use that y plus 2 factor right there, and we can exploit point-slope form to write both asymptotic equations as ones by finding that slope. And what is slope? It is rise over run. It is y over x, so it is 4 over 5 right there. So I have my asymptotes. I have my rectangular equation. All I need to do now is sketch the graph showing all the details. So I like to sketch from parametric form. Again, I think it is easier than rectangular form. They're both okay, but this is my preference, so that's what I'm going to do. So I see my x value center is 3, so 1, 2, 3. My y value center is negative 2, so 1, 2. So there's my center right there. I see a 5 with x is telling me 1, 2, 3, 4, 5. Plop. 5, 1, 2, 3, 4, 5 in both x directions. I see the 4 with the y is telling me up 4, 1, 2, 3, 4. Plop. And down 4, 1, 2, 3, 4. Plop. Bop, 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 bop. And now dash in the asymptotes going through the center and the edges of your box, just like that. All of them. Boom, boom. Boom, 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 boom. And it's horizontal, so use the horizontal points as your vertices and floop it out. Floop it and dupe it. We should show where our foci are, so we need to use our Pythagorean relationship, knowing that C is the largest piece, gets us C squared equals A squared plus B squared. What are A and B? Well, A and B are 5 and 4, so we know C squared equals 5 squared plus 4 squared. C squared equals 25 plus 16. C squared equals 5 plus 6 is 5 plus 25 plus 6 is 31 plus another 10 is 41. So C is the square root of 41. What is that roughly? That is roughly, well, let's see. 6 squared is 36. 7. Whoa, 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 whoa. I dropped my microphone, my bad. 6 squared is 36, 7 squared is 49, so I know I'm between 6 and 7. I know my vertice is already 1, 2, 3, 4, 1, 2, 3, 4, 5 away, so 6, 7, I have to be in between there, and then again 6, 7 have to be in between there. So there, those are plotted roughly in the correct spot, and I think we're good.